Hello guys, welcome back to another Intel Minds video. Today we're going to be talking about the chain rule. Let's get right into it. Let's let y equal 4u, and let's let some variable u equal to, let's say, half x. The question now is, how can we find dy dx in terms of dy by du and du by dx? Of course, we can always just substitute our variable u into this y function here, but the question is, how do we do that for more complex and very more complicated functions? So our solution is, we're going to find dy by du by taking the derivative of this function, the above function here, and that's going, of course, going to give us a variable 4. And also, if we take the derivative of du with respect to x, we're going to get our half here in the scene. Now we're going to substitute, and now to prove this, we're going to substitute u equals half x into our y equals 4u here. And we're going to get y is equal to 4 bracket half x. And of course, that's going to give us the answer y equals to, add there 2x. And it's the same as our answer. We're going to see dy dx is equal to 2, which is the same thing as dy by du multiplied by du by dx. It goes 4 times a half, which is also equal to 2. So this, in essence, is the chain rule. We're going to find some function, some derivative of dy by dx is actually given to us by right in the form of dy du multiplied by du by dx. So of course this might seem very easy to understand at first, if we're basically just adding this extra step of du in. It's actually going to become very useful as we get in deeper and deeper into these functions. There's a function within a function. An example would be to find the derivative of f of g of x, where there's a function within a function, which is a little bit harder to calculate on its own. And so basically what this chain rule is saying is that this part is the part of the outer function, and this part is the part of derivative of the inner function. If we recall our function from earlier, y is equal to, if we put it in the form of 4 bracket 1 half x, basically what this is doing is that we're taking the derivative of this outer part, which is going to be the 4, as well as the inner part, which is going to be half x. And that's what we're doing in that previous step there. And that's how we get our answer. So we can write this in prime notation. It's a little bit easier to see compared to Leibniz's notation. If you write f of x is equal to some function g, should probably use square brackets here, g of h of x, then the derivative of, the derivative f prime of x is going to be given us by g prime of h of x. Remember, this is the outer part. We're going to take the derivative of just the g multiplied by the inner part, which is going to be the h prime of x, the derivative of the inner function. So remember, this is the outer derivative, and this part right here is going to be the inner derivative. All right. So now we're going to do a few examples so you guys can understand a little bit better. We're given the function y is equal to 3x squared plus 5x with exponent 4 multiplied by root x squared is 9. So this does look like it's going to be a little bit lengthy. It is. I apologize if it's a little bit lengthy. Just bear with me here. So I'll talk about it step by step. If we take the derivative, recall our chain rule, we're going to take the derivative of the outer function, which means we're going to take First, this function, bring the 4 down. I'm going to rewrite the entire inner function as is. We're going to change the 4 to a 3. And then we're going to take the derivative of the inner function. If you take a look at this part right here, it's just going to be 6x plus 5. And that's the inner function. And also remember that we also have to apply product rule here. So the derivative of the first function, which is going to be, this is the first function, and this is the second function. That's our product rule. And we're just going to rewrite the second part of the function, or the second part of the entire, the second part of the function, just as is. It's going to be x squared plus 9. We're going to rewrite this as the exponent a half. And product rule means we have to add both sides. We're going to rewrite the first part of the function as is. And taking the derivative of this part, remember, this is what we're taking the derivative of, this entire function here. We're going to bring the half to the front, and this is going to be the derivative of the outside, negative half here. And now we got to take the derivative of the inside part function here. We're going to get 2x. All right, now that we've done basically the hard part out of the way, now we're going to make everything a little bit easier, simplify everything here. We're going to factor out some common factors here. We're going to factor out our 3x squared plus 5x exponent 3. We're going to factor out our x squared plus 9 to the exponent a half. And so we multiply everything. 4, we're going to get the 6x plus 5 here, as well as, let me factor out, oops, I'm going to add a negative here. We factor out a negative half of this function here. We're going to have to add x squared plus 9 to exponent 1. Because if we expand it, we're going to get this negative half plus this 1 is going to equal to a half. So that's how that's going to work. And add our second part here, which is going to be equal to an x. We're going to get the halves cancel out with this 2. We're going to x, and we're just going to get 3x squared plus 5x to the exponent 1. Since we factor out an exponent of 3 and this is exponent of 4, we're going to get an exponent of 1 here. And now, continuing on, we're just going to rewrite the common factors out. And in this step, we're going to be expanding the inner function here. And once fully expanded, we're going to get 24x here, 24x cubed plus 216x plus a 20x squared plus a 180. And that's this first part here, followed by our 3x cubed plus 5x squared, which is going to be the second part here. Last but not least, we're going to move this negative exponent to the bottom. We're going to put everything together on top. 3x squared plus 5x cubed. And now it's time we're going to simplify everything within this large square bracket. We're going to simplify it to 27x cubed plus 25x squared plus 216x plus 180 all over our exponent, our denominator of x squared plus 9. And actually, I'm going to, since it's to the exponent of a half, I can just write it as a root of x squared plus 9. And that is going to be our final answer. So if that was a little bit hard to follow along, just remember, guys, that we have to take the derivative of the outer function and then the derivative of the inner function. Let's just do another example so you guys can follow a little bit better. This one won't be as long, I promise. Y is equal to bracket x plus a cube root of x plus x squared. Exponent 20. So if we rewrite this, we can rewrite this as x plus bracket x plus x squared with exponent of 1/3, since this is a cube root. All to the exponent of 20. And now if I take the derivative of this, we're just going to get the derivative of the outside. We're going to move the 20 here, the outer function of 20. If this 20 was not here, we would go straight to taking the derivative of the inside. But since it is there, we're going to take this derivative of the outside, x plus bracket x squared. Everything on the inside is the same as is. We're going to change 20 to 19. And now we're multiplying it by the derivative of the inside here. We're going to get x going to 1 plus the third, 1/3 is brought down, 1/3 bracket. And then this is another inner part. So basically this question has 3 parts. We have this outer part, we have this function as this outer part, and we have this inner part. So we have this entire thing as an inner part, and then this as another inner function. So there's actually 3 parts you have to do to this question. And just for reference, if chain rule, if you think about if dy dx, in this case it would actually be, let's say, dy by some variable dz multiplied by some dz by some variable du multiplied by some variable du by dx. So there's 3-part components to this entire question. If we continue down here with our previous question here, so this inner part is going to stay the same, 2/3. And we're actually just going to multiply by this inner function here now. Just multiply on the side, 1 plus 2x. Everything in the brackets. And we're going to see here that it's going to be this 20 down here brought down, and everything in this middle and inside, and then the derivative of the inside here, and then the derivative of this thing multiplied here. And that is going to be the chain rule. All right, so now we're going to move on to the proof of the chain rule. The proof of the chain rule. So if we remember the limit of the remember the definition of the derivative, which is given us to as the limit as x approaches 0 of the difference in y, which is, let's just rewrite it as y2 minus y1, or x2 minus x1, which is, remember, the slope as the difference in x approaches 0. And I'm going to rewrite this in this form of limit as x approaches 0 of the difference in y, the difference in x, and as the difference in x reaches 0. Which basically, remember that the slope, or the distance between our slope and the actual slope of the real point approaches 0. You can rewrite this in the form of limit as x approaches 0, the difference of y divided by the difference of u multiplied by the difference in u over the difference in x. And so we're going to apply, what we did here was multiply and divide by the difference in u, delta u, which should not make any difference to the overall answer or the overall limits. Now we can apply the product property of limits and separate the two limits. We're going to get difference in y here, difference in u, delta y, delta u, multiplied by the other limit. This is the limit property. The product property. We're going to just separate these two limits as is. Delta u over delta x. And since delta u approaches 0 as delta x approaches 0, we can just rewrite this first part of this limit as the limit as delta u approaches 0, which would make a lot more sense here. And the second part we're going to keep the same. And this, remember, this is just going to be definition of the derivative here. So this is going to be dy by du, blah, blah, du by dx. And that is the proof of the chain rule by the definition of derivative. Highlight both your points here. Just so you guys have a better visual understanding of what is going on. This last part is going to be, since delta u approaches 0 as delta x also approaches 0. The last part is just by the definition of the derivative itself, as stated from the above portion here. And that is going to be the proof of the chain rule. Thanks so much for listening, and I'll see you in the next one.